Okay, so let's take the second problem we're going to look at. We want to know whether or not the function ln x over x to the 1/2 power, if the area under that curve is going to be converged to a fixed area, or will diverge and grow without bound, or maybe oscillate between different possible areas. So we're using the integral test. Okay, so we're going to integrate this function between 0 and 1. So this function is going to be a hard one to integrate. So I would suggest using the strategy of using integration by parts. Okay, so ln x, the log function, is usually a good function to take derivatives of. Okay, that's going to be 1 over x. And this is a polynomial, x to the 1/2 power. That one we could integrate. Well, x to the 1/2 on the bottom is actually the same as x to the negative 1/2, and that we could integrate. So, okay, let's go over integration by parts. When you want to integrate between a and b of u times the derivative of v, it's going to equal u times v evaluated between a and b minus the integral between a and b of v times the derivative of u prime. So let's call ln x u. Okay, and u prime, the derivative of that one is going to be 1 over x. And let's call v prime. Okay, we're going to call that, okay, x to the 1/2 power is the same, on the bottom is the same as x to the negative 1/2 on the top. So we're going to call that x to the negative 1/2. Okay, this is really 1 over this is x to negative. We're going to call that v prime. And then when we take the integral, the antiderivative of that, which is v, okay, we're going to add 1 to this exponent. That would make this to the positive 1/2. And then we need to divide by this new exponent. So when you divide by 1/2, that's the same as multiplying by 2. Okay, so this is what we get. Okay, so now let's use this formula and continue evaluating this integral here. So it's going to equal uv ln x times this, which is 2 x to the 1/2 ln x. Okay, evaluated between 0 and 1. Okay, minus the integral between 0 and 1 of v u prime, which is this, times that. Okay, so that we have x to, okay, so we have a 2 here. I'll pull out the 2. Okay, and then we have x to the 1/2 times 1 over x. Over x. And x to the 1/2 divided by x, this will simplify to give you x to the negative 1/2. Okay, dx. Okay, so now this integral, this one, we could integrate this without too much trouble. Okay, so let's integrate this one first over here. So, okay, minus 2. Okay, to integrate this, we're going to add 1 to this exponent. So that will give us x to the 1/2. And then we're going to divide by 1/2, which means to multiply by 2. So this will become minus 4. Okay, and then we evaluate it from between 0 and 1. Okay, so we're going to plug in 1 here. We get 1 to the 1/2 power is 1 times negative 4 is negative 4. Minus, and then you plug in 0 into this. The square root of 0 is 0. So this part is going to be 0. So all of this part is going to come out to be minus 4. Okay, so this part we computed is negative 4. Now this part here, when you're plugging in 1 into x to the half, that's 1. Ln x of 1, that's 0. So this whole part, we don't have trouble in plugging in 1 here. But the problem is when we plug in 0, okay, 0 to the half is 0. But 0 to the ln x is negative infinity. So when the function is getting very close to 0 at this point, this is negative infinity. This is going to approach negative infinity at 0. This is going to approach 0. And this is going to be indeterminate form. 0 times negative infinity, this is approaching it, pulling it towards 0. Negative infinity is approaching it towards negative, a very large negative number. And we can't actually determine, it's indeterminate. We can't figure out which one is going to win. So for this one, we're going to have to use L'Hopital's rule over here. So we just want to know around when x is approaching 0, what's going to happen to this function over here. So let's continue this over here. Okay, so we're going to take the limit as x is approaching 0. Okay, we're going to do it from the right because we're only interested between 0 and 1. We don't need to know about negative numbers. Okay, and ln x 2. Okay, and x to the half, let's write this as on the bottom, x to the negative a half. So if we write it as a fraction, we could use L'Hopital's rule. L'Hopital's rule would mean you take the derivative of the numerator, take the derivative of the denominator, and simplify, and then you could plug in, then take the limit and see what it becomes. And that would equal the same as this actual limit over here. So the x to the half, if you write x to the negative half on the bottom, that's the same as x to the half on the positive on the top. So I'm writing it like this to get a fraction. Okay. So now now you're going to use L'Hopital's rule. Okay, so the derivative of ln x is 1 over x. So we're going to get 2 over x. And on the bottom, x to the negative a half, the derivative will be negative a half. Okay, you pull that out front, and then you subtract 1 to that. So that'll give us negative 3 halves. Okay, so now let's simplify what we have here. Okay, we have a negative half on the bottom. So when we flip that over and multiply it by the 2, that will give us negative 4. Okay. Now this on the bottom here, this x here is really the same as, we could put on the top x to the negative 1. Let's write this x here. Okay, let's write it like this. X to the negative 1. Okay, and we're dividing that by x to the negative 3 halves. So you're going to subtract the exponents. Negative 1 minus negative 3 halves will be negative 1 plus 3 halves, which is going to give you x to the half. Okay, and remember, 2 divided by negative half will become negative 4. So all of this is going to become negative 4x to the half. And that's good because when we plug in 0, when you take the limit as x approaches 0 from the right, this is just going to become 0, all of this. So, okay, so we can say this is going to become 0 for this part over here. Good. So now back to the problem over here. When we're computing this at 1, we figured out this whole thing will equal 0. And when x at 0, we figure it out as well is going to equal 0. So this whole part is going to become 0. This whole part we computed is going to become negative 4. So the total answer is going to be negative 4 is what this integral will be. So therefore, it's going to converge. To -4. Okay, so we showed using the integral test that this function between 0 and 1, the area under that curve actually will come to be -4 and converge. Okay, thank you.